Welcome back to another video of AKL, Ivy Physics HL tutoring. This time we will be covering topic 1.2, uncertainty and error. All right, let's hop right into it. We're going to start off with random and systematic errors and kind of just determine the difference between the two things and what it could possibly look like on graphs and data and how that can be presented in multiple choice questions. So just to start off, we'll just make two columns. Random, and then systematic. So random errors, we'll fill out the random errors section first. Random errors are caused by, caused by fluctuations in measurements and those measurements are spread around a certain value. So it's kind of like if you're measuring the amount of time it takes for sulfuric acid to react with zinc, then the time you get is going to fluctuate a little bit from a certain value. And then this error can be reduced by having multiple trials. And it's important that you average them. These are not caused by bias. Okay, and then systematic error, on the other hand, is caused by fixed shifts. So you're going to have a shift in your data because you've started measuring at the wrong mark. So fixed shifts in measurements. So let's say you had a thermometer that was off by 5 degrees. Your entire data is going to be shifted over by 5 degrees. Cannot be fixed by multiple trials. So I'm just going to move on just to draw out systematic error and random error. So it could be that systematic error, let's just draw a little target. Oh, not a target. That's definitely not a target. A little target here with the middle being the accepted value. Your systematic error can be thought of as high concentrations of, I guess, relatively precise data, but it is not accurate. It's shifted over. And so most of the times, systematic errors can be described as precise but not accurate. Random error, on the other hand, is more so that the data is spread out randomly around the accepted value, like so. And yeah, that's about it for error. Okay, moving on to the next subtopic is absolute, fractional, and percentage uncertainties. So these are the three different ways of expressing it. So absolute, I'll just abbreviate with ABS, is delta, which signifies that this is the uncertainty of a certain measurement, x. Then you have fractional, which I'll abbreviate with frac, which is delta x over x. So that is the uncertainty of that measurement over the measurement. And then percentage, which is just the fractional times 100. So whenever you get an addition problem with two uncertainties, or that two measurements that have uncertainties, you can't just add them normally and ignore uncertainty. So there are certain procedures you have to do to make sure that you're accounting for that uncertainty. So for addition and subtraction, the formula is just the uncertainty of the final product, the sum of the uncertainties, is equal to the uncertainty of the first one plus the uncertainty of the second measurement. And from there, it looks normal. But when you get to multiplication or division, your uncertainty, well, first of all, you express it as the fractional uncertainty equals the fractional uncertainty of A plus the fractional uncertainty of B. And even if it's addition or subtraction, you still use this formula right here. You do not change it even if it's subtraction. Division. Same thing with this one. And if it is raised to a power, then so a to the n would be y, again fractional. The number, so this is the absolute value of that power times the fractional uncertainty of a over a. And that's pretty much it. And these two formulas right here, this power one and the multiplication and division, make sense. Because if these, let's say you had 2 plus or minus 2 times 2 plus or minus 2, you can either do it as a power with it being squared, or you can have it written the same way. And so it would be the fractional uncertainty, which is 2 over 2 plus 2 over 2 would equal delta y over, or let me write that on the other side. Delta y over y would equal 2 over 2, which equals 1, meaning delta y equals 1. So, and if you do it the other way, you would get the same result. So that just shows that those two, that's kind of like the proof between each two and the relationship between each of the two formulas for multiplication division, as well as the power. Okay, moving on to error bars. This is pretty much these are like give me questions on IB exam. These will come about mostly in the FRQ section of it. So they're pretty much just bars on points that indicate uncertainty. So just a picture of what they look like on a graph. So those are two points with error bars attached to them. And if you were to draw the line of best fit, you would want the slope to pass through all ranges of that. So there would be two lines of best fit, one passing through every single point, and then one passing through the upper bound and the lower bound. That's it for error bars. So moving on to vectors and scalars. This is 1.3, and we will be combining the two because they're pretty short. There's not really much to go over. So vectors have, let's do another T-chart. Direction as well as magnitude. Some examples include displacement, velocity, acceleration, and force. Scalar quantities only are dependent on magnitude only. Magnitude only. Again, distance. Some examples include distance, speed, time, and energy. So just to show the difference between, I'll make a quick little drawing between distance and displacement. So your distance, if you were on a circle or an oval, probably going to be an oval. Yeah, an oval. Your distance covered would be the path taken. So if you were to walk around this circle, starting here, all the way around, your distance would be the circumference of the circle. But your displacement would be 0 because you started and ended in the same spot, because it involves direction. And in this case, you are in the same spot, so you could not have moved in any direction because you've started and ended in the same spot. And that's it for 1.2 and 1.3. Hopefully you enjoyed the video, and I'll see you next time.